All right, so let's take a look at this example. We got 4x plus 2y equals 10, 2x plus y equals 5, and we're still looking at wanting to solve this by using the elimination method. Well, the second equation is almost like the first one. We're just missing a factor of 2. So let's multiply everything here times a factor of 2. Now that almost works, but we're going to need to make this a negative so we get something to reduce away. All right, so the first equation stays the same, 4x plus 2y equals 10. The second equation becomes negative 4x minus 2y equals negative 10. All right, so when we combine things, you'll notice that on the left side, the x is reduced away, the y is reduced away. So we have 0 on the left, and on the right, 10 minus 10, that's 0 as well. Now, normally you might think, oh, this is some kind of weird thing. This is no solution. But here's where you're wrong. This is a true statement. 0 equals 0. Essentially what we have is that these equations are exactly the same, which means we have an infinite number of solutions. So since we are unable to list every single solution, there's going to be a way that we want to write that. So it's going to be like this. What we want to do is we want to take one of these equations and solve it for one of the variables. Now, typically what you do is that if you have multiple variables, you want to have everything based off of the last one alphabetically. So we want to base this off of y. So if I take 2x plus y equals 5 and I solve this for x, we want to see how does x relate to y. So 2x equals negative y plus 5, and then x is equal to negative y plus 5 all over 2. So if we have a value for y, we could plug it into this expression and it tells us what the corresponding value would be for x. So it means that our solution set will look like this. It's going to be the set of all ordered pairs x, y such that x is equal to negative y plus 5 over 2 and y is any real number. So what this means is that you can pick any value for y, find the corresponding x value, and that's going to be a solution for this system. There are an infinite number of them. So for example, if you say, what if y equals 1? Well, if I plug in 1 right here, negative 1 plus 5 is 4. 4 divided by 2 means that x would equal 2. Which means the ordered pair 2, 1 would satisfy these equations. And you can easily check that because if I were to plug in 2 and 1 right here, 4 plus 1 is 5. That checks out. Or if I did this, if I said y equals negative 7. So if I plug negative 7 in right here, so it'd be negative 7, that's 7 plus 5 is 12 divided by 2, which means x equals 6. So another solution would be 6 comma negative 7. Again, there are an infinite number of solutions. I'm just doing a couple of examples here so that you can see that so as long as we have the form, we can write any solution that we want, right? You pick a value for y, it tells you the corresponding value for x, you write the ordered pair, and you have a solution. Again, there are an infinite number of solutions. So since we can't write all of them, we find a way to represent them, letting y be any real number, and then what is x based off of y. This next example is kind of similar to the last one, but you got to pay very close attention. Really pay attention to your signs, to multiplying, all the little stuff. So here, I see that the coefficients for x are already opposite signs. That's good news for us. So if I were to crisscross these coefficients, I'd have 6 down here, 9 up here. So 9 times 6x is 54x. 6 times negative 9x is negative 54x. That's great. These guys are going to reduce. Now, 9 and 6 have a common factor of 3, so I can actually make this problem smaller, make it easier on me. So reduce those guys by 3. And let's see what our system looks like. So we would have 18x minus 24y. 3 times 3 is 9. 2 times negative 9x is negative 18x. Positive 24y. 2 times 2 is 4. So now when I combine these terms, or when I combine these equations, the variables still cancel out just like they did in the previous problem, but now you'll see we have 0 equals 13. Now this is a false statement. I hope we all know that 0 does not equal 13. So we did everything right. All the variable terms canceled out, and what we're left with is a false statement, which means that there is no solution. There will be no ordered pair that satisfies both of these equations. And if you were to look at the graph of this, that means that these guys are parallel lines. Remember, parallel lines are coplanar lines that never intersect. All right, so just like we saw in the last problem, if 0 equals 0, that means true. It means you have an infinite number of solutions, so you have to find a way to represent them. But if you end up with a false statement when all the variables cancel out, well, there's just no solution. So pay attention to that, keep that in mind, and you'll be all right.